4.5. Write equations of parallel and perpendicular lines. Remember, parallel lines are two non-vertical lines in the same plane with the same slope. So if we look at this picture to the right, I can label for the slope of line A to be M1 and the slope of line B to be M2. And therefore, the slope of line A would equal to the slope of line B. On the other hand, perpendicular lines are two non-vertical lines also in the same plane but with slopes that are negative reciprocals of each other. So they intersect to form a right angle. Okay, so for line A, we could let the slope be M1, and for line C, I could let that slope be M2, and then M1 times M2 would equal to -1. So here, double check that, 2 times -1/2 equals -1. So we describe this as slopes that are negative reciprocals of each other. Guided practice, part A. Write an equation of a parallel line that passes through the point -3,5 and it's parallel to the line y equals 3x minus 1. Well, you have three options. You can either use 1, the y-intercept form, 2, the point slope form, or 3, the standard form. To find your equation of the line. I am going to choose the y-intercept form because I find it easier. So let's set it up. Y equals mx plus b. Now I have the slope here, 3. In order for the line to be parallel, they need to have the same slope. So I'm going to sub that in for m. And I have a point here. -3 is my x. 5 is my y. And I can solve for the y-intercept. So my y-intercept b would equal to 14. Now I can rewrite my equation now as y equals the slope of 3x plus 14. And you can leave it in slope-intercept form. It's okay. Part B. Write an equation of the line that passes through the given point and is parallel to the given line. So again, we need to find out what the slope of this equation is. So they give it to you in standard form. So I know my A is 8, my B is 2, and C is 11. And I could use slope equals negative A over B to find my slope. So that turns out to be negative 4. And now, again, I'm still going to use the slope-intercept form to find my equation of the line since it's easier to work with. 4, and slope is negative 4. X is negative 1, and solve for my y-intercept. And your y-intercept happens to be 0, which makes things even easier. Therefore, y equals negative 4x. Well, I'm going to show this extra step here. You don't need to write this as your answer. So therefore, y equals negative 4x. So this would be the equation of the line that is parallel to the given line 8x plus 2y equal to 11 and passes through the point negative 1, 4. Part C. Write an equation of the line that passes through the given point and is perpendicular to the given line. Okay, so first we need to look at the given line and find out what the slope is. Now we can rewrite this in standard form, 9x plus negative 6y equal to 4. Therefore, the slope will be negative a over b. So your a value will be 9 and your b will be negative 6. Now the negative signs cancels out, and after simplifying 9 and 6 you get 3 over 2. And the perpendicular slope will be given by 2 over 3 and putting a negative sign in front of that, because we need negative 2 over 3 is the negative reciprocal of 3 over 2. The product of these two slopes would be equal to negative 1. Okay, now I'm going to use the slope-intercept form to find my equation of the line. Y equal to mx plus b. So y here is negative 3. Perpendicular slope is negative 2/3. X is 17 plus b. Now I'm going to show all the steps so I don't make a careless mistake. So b, the y-intercept, is positive 25 over 3. Now I can write my equation of the line. Y equals to the perpendicular slope negative 2/3 x plus the y-intercept 25 over 3. And to be 100% sure that your equation of the line is correct, you can go ahead and substitute in the point 17, negative 3 in to check. So 17, negative 2/3. This gives you negative 34 over 3. Negative 34 over 3 plus 25 over 3 gives you negative 9 over 3, and that equals to negative 3, which is your y value. So check. This is the right equation that is perpendicular to the given line. Part D. Determine which of the following lines, if any, are parallel or perpendicular. Okay, before I even compare their slopes, I need to first find out what the slopes of all the lines are. Okay, so for line A, the slope is 2/3 because the line is already in slope-intercept form. For line B, we need to rearrange the terms a little bit so that it's in standard form. Negative 3x with the x variable in front plus 2y equal to 5. In this case, we can use the slope equals negative a over b formula. So your a value will be negative 3 and your b value will be positive 2. So slope will be negative 3 over positive 2, which is 3 over 2. And for line C, they give you the equation of the line also in standard form, this time with the variable x in front. So this would be 6x plus negative 3y equals to 10, and we can apply the slope equals negative a over b formula again. So the value of your a will be 6. So I'm write negative 6 here, and then the value of b will be negative 3. And your slope will be positive 2. Okay, remember that this negative sign here is already there, so 6 is actually just positive 6. Okay, so now that we have all three slopes, let's first find out if they're parallel. Remember, parallel, when lines are parallel, all the slopes need to be the same. So 2/3, 3 over 2, and 2 are all different. So, nope, parallel. We could just write not parallel. And perpendicular, let's see if any pairs are negative reciprocals of each other. 2/3 times 3 over 2 gives you 1, but not negative 1, so not parallel. 2/3 times 2 is obviously not negative 1, and 3 over 2 times 2 is 3. That's also not negative 1, so not parallel and not perpendicular. So you could just write the symbol perpendicular or just write out the word perpendicular. And just to add a side note, the symbol for parallel is just 2 lines. Word problems. The cost of bowling includes $4 per game and a shoe rental fee. Shoes for adults cost $2.25, and for children, shoes cost $1.75. Write equations that give the total cost of bowling for an adult and for a child as functions of the number of games bowled. So I'm still going to use y equals mx plus b as my strategy in setting up 2 equations here. One for adults, one for a child. So because of this sentence, I know total cost will be my y. And x will be the number of games bowled. Now we need to find 2 different equations here. One for an adult and one for a child. So for the adult, the changing variable is $4 per game, and the fixed cost is $2.25. And for the child, the equation will be y equal to 4x plus $1.75. So here we have both equations. And how are the graphs and the equations related? As you can see, the slopes are the same and the y-intercepts are different. Therefore, we can write the graphs have the same slope but different y-intercepts. Because the fixed cost for shoes between adults and children are different. On a street map, Main Street and Maple Street can be modeled by the equations y equals ax plus 6 and x plus 2y equal to 4. For what value of A are the streets parallel? For what value of A are the streets perpendicular? Justify your answers. Okay, so I'm going to write down the two equations. Okay, and I'm going to set this as line 1, line 2. Okay, so for the first equation, the slope is A. For the second equation, the slope is negative 1/2. Now, in order for the two streets to be parallel, their slopes need to be the same. So when they're parallel, M1 needs to be equal to M2. So A equals to negative 1/2. When the streets are perpendicular, M1 times M2 equals to negative 1, meaning their slopes need to be negative reciprocals of each other. So I'm going to let M1 equal to A, M2 is negative 1/2, and we can solve for A, and A equals to 2. And that's it. And this concludes our lesson.